Hello, this is section 9.5, Solving Applications of Quadratic Equations. Part 1, Applications. Recall our strategy for solving word problems. I'll give you a moment to read this on your own. If you need more time to read it, feel free to pause the video now. Example 1. The product of two consecutive even integers is 168. Find the integers. Well, our first integer, I don't know what it is, so I'll just call it x. And then our second integer, well, I know it's a consecutive even integer, so that means it's 2 further. So x plus 2. So now the product of these two numbers, or x times x plus 2, is 168. Now we have a quadratic equation that we can solve. I'm going to distribute the x first, get x squared plus 2x equal to 168. And now I'm going to complete the square, but you could try to factor it or whichever method you like. I'm just going to complete the square here. So 1/2 of 2 squared, 1 squared, 1. So I add 1 to both sides. X squared plus 2x plus 1 equals 169. That factors as x plus 1 squared equals 169. Take the square root of both sides. Absolute value of x plus 1 is equal to 13. X plus 1 equals 13. Or x plus 1 equals negative 13. Subtract 1 from both sides of both equations, and we get x equals 12, or x equals negative 14. So we have two options for x. So either the first integer is 12, which makes the second integer 14, or the first integer is negative 14, in which case the second integer is negative 12. Now, the reason why we get two answers is because two positive numbers or two negative numbers will both give us a positive answer. Example 2. An architect is designing the entryway of a restaurant. She wants to put a triangular window above the doorway. Due to energy restrictions, the window can only have an area of 120 square feet, and the architect wants the base to be 4 feet more than twice the height. Find the base and the height of the window. Recall the area of a triangle is given by A equals 1/2 BH. Okay, so for this one, I'm going to start off by drawing a picture instead of labeling my unknown quantities. And what I know is the base is 4 more than twice the height. So if this is the height, then we need 4 more than twice that. So 2h plus 4. So this is the triangle that we have. And we have that the area, the most it can be is 120. So I get 1/2 times the base times the height has to equal 100. I multiply both sides by 2 first so that the 2 and 1/2 cancels out. And then I'm going to distribute that h. So we get 2h squared plus 4h is equal to 240. I'm going to divide by 2 on both sides and get h squared plus 2h is equal to 120. And again, you could factor it or quadratic formula, but I actually think completing the square is the easiest way this time again. So I'm going to go 1/2 times 2 squared, which is 1 squared, which is 1, and add 1 to both sides. We get h squared plus 2h plus 1 is equal to 121. That factors as h plus 1 squared, which equals 121. Take the square root of both sides. We get the absolute value of h plus 1 is equal to 11. So that implies that h plus 1 equals 11, or h plus 1 equals negative 11. Subtract 1 from both sides of both equations. We get h equals 10, or h equals negative 12. Well, since h is representing a height here, it cannot equal a negative number. So we have h equals 10, and then the base would equal, well, 2 times 10 plus 4, or 24. Example 3. Mike wants to put 150 square feet of artificial turf in his front yard. This is the maximum area of artificial turf allowed by his homeowners association. He wants to have a rectangular area of turf with length 1 foot less than 3 times the width. Find the length and width. Round to the nearest tenth of a foot. So we get rectangle this time. And I want the length to be 1 foot less than 3 times the width. And then there's the width. So now the area of a rectangle is just length times width. So W times 3W minus 1 is equal to 150. Distribute W, we get 3W squared minus W equal to 150. Subtract 150 from both sides, and we get 3W squared minus W minus 150 is equal to 0. Now you can try to factor this one. It's not going to work though, so I'm going to use the quadratic formula. So with A equal to 3, B equal to negative 1, and C to negative 150, we get that W is equal to negative B, so 1 plus or minus the square root of B squared, so 1, minus 4 times A times C, which is negative 1800, all over 2A, which is 6. This becomes 1 plus or minus the square root of 1801 over 6. Now I'm going to actually drop the negative sign because we can't have a negative answer. So then our answer is just 1 plus the square root of 1,801 over 6. And it says round to the nearest tenth of a foot. And this comes out to be approximately 7.240. And the nearest tenth of a foot would be 7.2. Now for the length, which is 3 times W, so 7.2 minus 1, would equal 20.6. That's a good place to stop for this part of the notes.